All right, so Chapter 6, Lesson 7 is equivalent expressions. The vocabulary startup, you guys wrote down this vocabulary, will help you answer the following questions. So, a term is each part of an algebraic expression that is separated by addition or subtraction signs. Okay? The coefficient is the numerical factor of a term that contains a variable. Okay? It's a coefficient. So it's the number in front of the variable. Right? That's how you'll see it. A constant is a term without a variable. So it's just the number. Okay? And the reason why they call it a constant is because it never changes. A 3 is a 3 is a 3, right? It doesn't change. Like terms are terms that contain the same variables. Okay, so if they both have x's, then they are like terms. Okay? So, in the expression 3n plus 5p plus 2 plus n, we want to list all of the terms of the expression. Okay? So the terms, remember, they're separated by addition and subtraction, right? So the terms are what? 3n, 5p, 2, and n. Very good. So the terms are 3n, 5p, 2, and n. So now we want to list the like terms of the expression. Now, the like terms have the same variable. So which ones here have the same variable? 3n and n. Very good. By the way, what number is in front of that n? In front of this n?
2.
Well, how many n's do you see there?
1.
There's 1, right? There's 1 n there. So here, when you have no number in front of the variable, it's a 1. Okay? Is everybody clear with that? So that is 1n. Because 1 times n is just n. And that's why we can write it just n. Is everybody clear with that? So here, your like expressions, your like terms, are 3n and n. So now we want to list the coefficients of the expression. So remember, the coefficients are the numbers that are in front of the variable, right? So here, what are the coefficients? 3, let me write it smaller. So 3, 5, and there's one more. And what? And 1. Very good. The 1 that is in front of the n is also a coefficient. Very good. So that's 3, 5, and 1. Okay? And now we want to list the constants of the expression. Remember, the constants are just the number. So here, the constant is 2. Very good. So there is our constant. All right, so here we are going to simplify expressions with one variable. Okay? Now I do want you to write down this rule. To simplify an algebraic expression, we're going to use properties to write an equivalent expression that has no like terms and no parentheses. Okay? So here, these are examples of simplifying using numerical terms and using algebraic terms. So, for example 1, it says simplify the expression 4 times quantity 6x. Now, if I reread this, okay, it's all multiplication, right? It's all multiplication. So, I could read this as 4 times x, 4 times 6 times x. Okay? Now, we're going to show our properties here. So, because it's 4 times 6 times x, and we want to combine our like terms, That means here on this one, we want to multiply the 4 and the 6. So here, if I move my parentheses from the second two terms to the first two terms, to the first two factors, then I can multiply the 4 and the 6. So 4 times 6 is 24, and we end up with 24x. So then we'll do this quadratic problems. For problem A, we have 3 times x times 11. Okay, 3 times x times 11. And we're going to show the movement of each one of our properties, okay? So here, I want to multiply the 3 times the 11, right? So we want to get those closer together, okay? So what I'm going to do is I'm going to flip the 3 and the x. What property allows me to flip the 3 and the x? The commutative property of multiplication, right? So here we're going to have x times 3 times 11. And now we can just multiply, right? So here, so now the parentheses are, we can put the parentheses from the second two from the first two to the second two. So now we can multiply 3 times 11, and that gives us 33. So this is going to be x times 33. Now in algebra, we always put the number or the coefficient before the variable. So the number always goes first. So the way I want to write this is 33x. 33 times x. And the property that allows me to flip that around is the commutative property of multiplication. Very good. All right. So this one, we have x plus x. What's in front of each one of those? 1. Very good. So we've got a 1 right here. We've got a 1 right there. And we've got a 1 right there. Okay? So this is going to be, when I add this, 1x plus 1x is 2x, plus another 1x gives me 3x. And there's your final answer. Okay? Now, I want to let you know that eventually we won't have to show all of the movement. Okay? By the end of this lesson, we're just going to be circling our like terms. Okay? So, why don't you guys do letter C on your own. All right. So we have 7x plus 8 plus 1x, right? You don't always have to write the 1, but I'm just going to write it for now, just as a reminder for you. So this is going to be 1x. So 7x plus 8 plus 1x, okay? Now we want to put our like terms together. Which ones are the like terms? 7x and 1x. Very good. So we want to put those closer together, right? So I'm going to flip the 8 and the 1x. All right. So now we have 7x plus x plus 8. And now we can combine our like terms. So 7x plus 1x is 8x. And then we're adding the 8. Can I put those together? The 8x and the 8? No, I can't. Those are not like terms, okay? This is like saying, you can't put apples and oranges. You're not going to see apples and oranges in the same bushel at the grocery store, right? You're going to have apples with apples. You're going to have oranges with oranges. And you're not going to see them added together in the same bushel. Is everybody clear? So here, because this is an x term, and this is a constant, that's apples and that's oranges, and we cannot put them together. Is everybody clear with that? Everybody good? All right, so for example 2, it says 3 friends will pay X dollars each for admission to the museum, plus $1 each to view the mummy exhibit. A 4th friend will pay admission but will not view the mummy exhibit. write and simplify an expression that represents the total cost. Okay? So, the important information in this word problem is that we're going to pay X dollars each for admission, right? And we're going to pay $1 each to be the mummy, right? And also we know that we have a fourth friend who will pay admission but not see the mummy, okay? So how many people are going to see the mummy? Three, right? 3 people are going to see the mummy. So here, this number right here tells me that's how many people are going to see the mummy. The information inside this parentheses tells me that that is what people are going to, that's how much people, somebody has to pay, that's the admission, the X, plus the $1 to see the mummy. So this is all the people who are going to see the mummy. Is everyone with me? Then we have that fourth friend who's going to pay for admission to the museum but not see the mummy. So how much is that person going to pay? Just X, right? Just X. And that is right here. Just the X. Is everybody clear with that? So this is the expression 3 times the quantity X plus 1 plus X. That is the expression that we're simplifying. So the first thing we need to do here to simplify this expression, to get rid of those parentheses, what do I have to do? Starts with a D. The distributive property. So here, we want to do the distributive property. So, we have 3 times X, which is 3X, and 3 times 1, which is 3, and then we bring that X over. So now we have 3X plus 3 plus X, and now we can simplify. So here, we want the X's together, so we're going to flip this X and this 3, that's the commutative property of addition, and now we can flip the 3X plus the 1X together. We get the 4X plus 3. So that is the expression that tells us the total amount that everybody's going to pay when they go to the museum. This problem, this guided problem, letter B, we're still going to use the information from the previous example, okay? So it says write and simplify an expression for the total cost of 6 friends to go to the museum if only 4 friends view the mummy, okay? So let's write our important information, okay? So we've got the cost of admission was X dollars, right? Make sure you write down your important information. It costs $1 to see the mummy. $1 to see the mummy. How many friends are going? 6. 6 total friends are going. 6 friends are going to the museum. Okay? How many are going to see only the mummy? I mean, going to the museum, but they're and they're going to see the mummy. 4. Very good. All right. So 4 friends view the mummy. Okay? So how do I write how much the 4 friends are going to pay? How much is how much is 1 friend going to pay to go to the museum and see the mummy? X dollars plus $1. Very good. So that's X plus 1. So that is how much for admission and to see the mummy. How many friends are going to see the mummy and go to the museum? 4. So this, we're going to multiply times 4. You with me? The other 2 friends are not going to see the mummy. So how do I show how much they're going to pay? They're only paying for admission, right? There's 2 of them. So X times 2. Very good. So we're going to add 2X. And here is our expression to show how much the total cost will be. Okay? So, let's simplify it. Okay, so the first thing I need to do to get rid of the parentheses is what? That's with a D.
Distributive property.
The distributive property. Very good. So here, we're going to distribute the 4 throughout the parentheses. Okay, so we have 4 times x is 4x. 4 times positive 1 is positive 4. Very good. And then we have plus 2x. So we're just going to write that. Is everyone with me? All right. Now right here is where I'm going to tell you, let's just circle our like terms. Okay? So what are the like terms? 2x and 4x. Very good. So we have the 4x and we have a positive 2x. Okay? So now we can combine them. So 4x plus 2x is equal to 6x. So here we have 6x. And now we just have that 4 left over, right? So plus 4. And this is the expression that shows you how much, the simplified expression of how much the total cost would be to go to the museum for those 6 friends. So now we're going to simplify expressions with 2 variables. Please make sure you write your heading. We're going to simplify expressions with 2 variables. Okay? So here properties can be used to simplify or to factor expressions with 2 variables. We want to compare the effects of the operations on numbers to the effects of operations on variables. Okay? So in this section, we are going to simplify and we're going to factor expressions. Now, when they're talking about comparing, I want you to take a look at what happens with numerical terms and what happens with algebraic terms. Okay? So, for the numbers here, we've got 3 plus 3 plus 4. Okay? 3 plus 3 we can rewrite as 2 times 3. Right? If I simplify that, I'm going to get 2 times 3 is 6, plus 4 is 10. So here, I can simplify all the way to one number, right? If I look at the variable, the algebraic expression, here I have x plus y. The x plus x we can write as 2x, right? Plus y. The difference between the numerical and the algebraic is, can I put that 2x together with that y? No, I cannot put them together because they are not like terms. Is everybody clear with that? So here, this is my final answer, 2x plus y. So, example 3 says to simplify the expression 14y plus x plus 22y. So here, going back to showing all our movement with our properties, okay? So, starting with the 14y plus x plus 22y, we want to add, which ones are the like terms? The 14y and the 22y. So we want those to be closer together, okay? So here I'm going to flip the 14y plus x, and I'm going to write that as x plus 14y. The property that allows me to do that is commutative property of addition. Very good. So now I want to take those the parentheses and I want to move them from the first 2 to the second 2. Is everyone with me? So what property allows me to move it to the second 2 terms? Associative property of addition. And then we can combine our like terms. So here we have x plus, and then here the 14y plus the 22y gives me 36y. Okay? You will also notice in algebra that you see how they have the x first and the y first? If they had a b, a c, and an a, they would write the terms a, b, and then c. They usually write them alphabetically. Okay? All right. So, for example 4, we want to simplify 4 times the quantity 2x plus y. And on this one, the first thing we're going to use is our distributive property to get rid of our parentheses. So, we're going to take that 4 and we're going to multiply it times everything inside the parentheses. So 4 times 2x and 4 times y. So 4 times 2x is 8x and 4 times y is 4y. The next example is factoring algebraic expressions. Still, it's the same as what we were doing before. So here, we want to see what is the GCF with 27x and 18y. The number that can go into both those numbers is 9, right? So here, we're going to rewrite the 27, we're going to say 9 times 3x. Remember we had one like this yesterday? 9 times 3x. And then the 18y, we're going to write 9 times 2y. And now we can take that 9 out, and it goes in front of the parentheses, and whatever is left stays inside the parentheses. So we have 9 times the quantity 3x plus 2y. So let's simplify problem E. Simplify 3x plus 9y plus 2x. Okay? So on this one, on these, I'm going to go ahead and say that we're just going to circle our like terms. Okay? So what are the like terms here?
3x and 2x.
Okay. So we've got a 3x and we have a positive 2x. So 3x plus 2x is 5x. 3 plus 2 is 5. So that's a 5x. And then we're going to add 9y. Is everybody clear? All right. What am I going to do with letter F? We are going to simplify because it says simplify. But how are we going to start it? There's parentheses. I want to get rid of the parentheses. What am I going to use? The distributive property. Very good. So, we're going to take that 7 and we're going to distribute it throughout the parentheses. So here, when we multiply 7 times 3x is going to give me 21x. Plus 7 times y is 7y. And that's your final answer. For letter G, we're going to factor. Okay? So we're not simplifying like we were in problem E and F. This one we're factoring. So we want to know what is the GCF of 12x and 8y. 4. Very good. So when we rewrite, we're going to write 4 times 3x plus 4 times 2y. Does everybody see if I multiply those, I'm going to end up with the same thing that I started with? Okay? So now we can take that GCF out. So now the 4 can come out of the expression. And where does that go? In the front of the parentheses. So the 4 goes in the front of the parentheses. And what is left?
3x and 2y.
Very good. 3x and 2y. So that stays in the parentheses. We have 3x plus 2y. And that's your final expression. So for example 6, it says the farmer's market sells fruit baskets. Each basket has 3 apples and 1 pear. We're going to use A to represent the cost of each apple, and we're going to use P to represent the cost of each pear. We want to write and simplify an expression that represents the total cost of the 5 baskets. So first we can say, okay, we can figure out how much it's going to cost for the fruit in 1 basket, because we know that there are 3 apples and there's 1 pear. You don't have to write the 1, but I just wanted to show you that that's 1 pear. And then this right here, this is the expression for the cost of 1 basket. So now we want to figure out how much it's going to cost for all 5 baskets. So this expression, we're just going to multiply times 5. Okay? So once we do that, then we can go ahead and use our distributive property. And 5 times 3a is 15a. And 5 times 1p is 5p. So this is our expression that tells us how much it's going to cost for 5 baskets of fruit.